How will the COVID-19 outbreak change public buildings, and what can be learned from healthcare design? Fleet architects are experienced designers of all public and social sectors. We recently prepared a presentation speculating on how community healthcare premises, including GPs, will adapt to new ways of working post-COVID-19. This presentation considers how some of the same factors will impact the use and design of public buildings. The presentation also combines input from the Building Engineering Department at Sweco. Our objective is to provide a range of considerations that will help operators to plan for viable reopening and future design by adopting a building-specific risk-assessed approach. Understanding the new safe capacity of your building is critical and is dependent on a variety of factors. While this process has specific relevance to the current pandemic, building in functionality will help organisations to respond to similar future crises. We need to rethink arrival. Queuing and queuing space could be problematic, but might also be an opportunity. More staff and visitors will arrive on bike, on foot, or, unfortunately, by car. These need to be planned for. Working with local authorities, landlords and neighbours, take advantage of new opportunities, seek to extend the experience beyond the threshold. We must promote continuous flows by minimising entrance eddying and the demand for interaction at the ticket office, information desk and cloakroom. Increased use of e-tickets and barcode scanning is recommended. Consider the case for security and BMS systems to allow this. Explore extending the anti-spaces into gardens, terraces, or neighbouring external spaces, which can be accessed to increase waiting space when capacity pressure is anticipated and social distancing threatened. Consider temporary structure or pavilions to increase capacity or broaden events programme. Identifying the type of flows you experience when in operation is key. Principally, flows will either be fluctuating, continuous, or combinations of both. Ancillary space capacity may limit acceptable numbers more than revised venue numbers. Many of the risks and opportunities are common for more than one use. We have picked out some differing building and flow types. Small single-room venues with continuous flows, e.g. restaurants, bars, small theatres, private galleries. Large single-room venues without continuous flows and greater ancillary spaces, for example, auditoria. Large multi-room venues with unrelated flows, for example, multi-stage theatres, cinemas and multimedia institutions. Large multi-room venues with continuous linear flows, for example, larger galleries or museums. Complex institutions, with varied flows of all types, could be subdivided to separate conflicting flows. Circulation flow capacity will inhibit the use of the event spaces and may prevent feasibility of even the revised capacity numbers. Circulation areas present a range of transmission risks arising from physical contact points, for example lifts and lift controls, handrails, door handles, and narrow stairs and corridors which prohibit social distancing. Competing flows can be reduced and social distancing promoted by one-way systems and dedicated access and egress points. If the current exit is via a vending area, the risks of slowing flows will need to be addressed. One-way systems will allow visitors to return to a particular facility, the toilets, for example, without egress or countering flows. Large home stores are a useful precedent, with parallel fast-track and backtrack routes. Be wary of over-provision of signage, which creates visual noise and can deter compliance. Consider restricting direct access into the building to manage numbers at capacity. Measures such as door releases triggered by use of sanitizer dispensers will help improve hygiene. Explore using technology and media to reduce the need for ticket or information desks, but where unavoidable, consider measures to guard staff and visitor safety. Adding reinforced screens will protect staff and visitors from transmission, but interaction at the reception, ticket office or information desk is often the first contact point and can impact stress and quality of visitor experience. Could deeper reception counters help to reduce risk of cross-infection without diminishing communication quality? Regardless of seating arrangements, cleaning regimes, and how effectively facilities and contact points can be cleansed, must be risk assessed and adapted, including materials used. Porous acoustically softening materials used for auditorium seating are often difficult to clean. Ventilation can impact sharing of airborne infection. Auditoria and theatres traditionally employ air displacement style systems, with air introduced at the front of the theatre or underneath seating and extracted from the rear of the room or via a perforated ceiling. This works well as pollutants in the air are moved away from people and, in the case of ceiling extract, drawn upwards. Imposing social distancing of 2 metres, the current UK guideline, will greatly reduce capacity, and the removal of seats may be required to increase the number of circulation aisles and prevent close passing. Social distancing of 1 metre, the proposed World Health Authority recommendation, will reduce capacity by a smaller degree, perhaps 50%. Group sizes will vary. As regulations are eased, the bubbles of interactions will increase beyond single households. Social distancing could be observed with capacity maximised by using smart booking tools to allow for variance of group sizes and reduce the costly need for physical adaptation. Segregating areas for those identifying as high risk could be a sensible safety measure. We estimate that cafes and restaurant capacity will reduce by at least 50%. Tables can be demarked for A and B sittings to permit socially distanced dining, with thorough cleaning taking place during changeover. Exploring the use of technology to pre-order from online menus permits more shorter sittings and compensates for the loss of tables at peak times. Booths in dining rooms may offer more protected environments, but they may be a greater risk due to tighter planning and soft furnishings. Reducing the use of serveries and bars should be an imperative. The design of ventilation can increase or decrease the risk of sharing an airborne infection, and may govern the appropriate social distance measurement. Localized extract, which does not draw air past other diners, will have less risk and could justify reducing distancing measures. Running of ventilation for longer periods or overnight will also cleanse the air. Gardens, terraces and streets should be considered for expansion of dining rooms, though social distancing is still required in the open air, although the risk is reduced by the greater volume of air. Cross-programming spaces may also offer more opportunity to experience an exhibition if time limited and as part of a programmed flow. Counter service will give rise to queuing. Queuing while social distancing demands additional space and introduces more risks to visitors and staff. Point of sale in shops should be considered in a similar fashion. Where unavoidable, screens to separate queues and customers from staff should be installed. Events and attractions which host standing crowds will be severely restricted. Social distancing requirements at any of the current levels will greatly reduce capacity and inhibit atmosphere of a live performance. Exploring measures to minimise risks and maximise capacity will be critical. Increased ceiling heights give a greater air volume and may reduce infection risks, and, it therefore could be argued, justify a shorter social distancing measure is used. Mechanical extract at high level, promoting the air change rate and drawing air away from the visitors, will reduce cross-infection risk and may reduce the case for extreme social distancing further. As with other instances, if ventilation can be run for longer periods or overnight, it will reduce risks. Where crowded standing events are not practical or viable due to social distancing, can spaces and experience be augmented by other uses, such as dining or drinking? Toilet capacity may reduce the building capacity. As elsewhere, toilet queues must be managed. One-way systems will be an advantage and prevent cross-flows. Hand sanitizer could be used to activate doors. Wide corridors, greater than 3 meters, will also allow for good levels of social distancing, even with return flows. Narrow corridors, less than 3 meters, without the opportunity for a one-way flow, may need divider screens, although if the ceiling is low, the limited air volume either side of the screen could conceivably enhance infection risks. As with most internal spaces, additional air volume through greater width or ceiling height will assist with reducing the risk of sharing contaminated air. Toilet ventilation will often use make-up air from common areas. Future design should avoid this. Existing buildings should consider the impact on safe numbers in spaces. Wash basin numbers and proximity will be the single largest limiting factor of the number of users permissible in a toilet at any time, not the number of cubicles. The large number of contact opportunities in a toilet pose a great risk of passing on infection, and should be reduced where possible, with non-contact taps, dispensers, flushers, and hand dryers installed as standard. Gender toilet designation does not fit the operating of most modern institutions. Enlarging all toilet cubicles to include wash basins and drying, the superloo arrangement, is both best hygiene practice and less discriminatory. With fewer visitors likely, how can venues explore using technology to broaden access? While not a substitute for the live experiences, technology could offer digital extensions to events compromised by the need to socially distance. Such solutions are also more inclusive for those socially isolating. Remote virtual experiences, hard and software to create enhanced virtual experience, are widely available and easily installed. For instance, laser image drones, wire cameras, commonly used in the property industry, could be employed to create quick and interactive experiences. Office operation is likely to be changing in the longer term, and we are finding several common factors across workspace projects. Reduced workspace capacity and more home working. Redesigning office spaces for social distancing. More virtual meeting capacity. Generally and building-wide, we must also consider risk assessing cleaning processes of public and private areas, maximising the opportunity for good hygiene, and what PPE is appropriate for staff and visitors, and how it is distributed. In summary, calculate maximum capacities and adjust for the risk and limiting factors identified. Understand interaction between activities and explore programming flows into linear experiences to maximise the safe visitor number. Audit and adapt circulation and ancillary spaces to support new flows, blur boundaries, and enrich the experience from arrival to exit. If you'd like to discuss the specific risks and opportunities of your own venues, please do contact Fleet Architects on the details below.